Hi guys, here's a video on friction, and it is just basically an introductory on friction force, basically covering N2 and N3. Feel free to share with your friends, they might also find it useful. Okay, so friction is a force. Friction is a force, so we know what force is. Force is an influence that tends to change the state of motion of an object. Force, basically, from what we have learned so far, force tries to bring about acceleration or deceleration. So friction force, it is now an opposing force. So for friction force, we'll be using that force with that symbol there, or if you want, you can use F, which is still fine. It's a friction force. So basically we know the units for force, so which means the units for force is newtons. Friction force, it is also a force, the units is going to be newtons. So the same way friction force will also have the same units as a force. It's just a force. So friction force is an opposing, so it is always in opposition to the applied force. So friction force is always in opposition, it opposes. If you say we have got an object, we try to push this object in that direction, this is your force applied, friction force will change and start going in that direction. If you say, okay, let's not push this object that side, let's pull this object in that direction, friction force will be pulling in the opposite direction. So friction force will always oppose your applied force. Then the other thing about friction that we need to know is that friction force is a contact force. Friction force is a contact force. It depends on how much force or how much contact there is between two surfaces. Earlier in our dynamics, we learned about force, and it's just a force that was being applied. But then with friction force, it depends on how much contact we have an object and how much contact this object has against the surface. If there is too much contact between the surface and the object, these two, the object and the surface, they are too much in contact, then there is too much friction. If there is not so much contact between this object and that object, then friction will not be that much. So friction force is a contact force, and also it is always in opposition. We do not apply friction force. Friction force just comes about as a result of the contact of two surfaces. This surface and that surface, we have two objects, object A, object B. This is in contact with that object, therefore friction force exists. So which now brings us to us knowing Newton's third law, which we should have known by now. And most people memorize it to say when object A exerts a force on object B exerts an equal force on object A, but in the opposite direction. So in the same manner, the contact of this object on this surface depends on the weight of this object. So now when we speak about the weight of the object, is how much this object is pushing against the surface. And we'll be looking at what is known as the normal reaction. Normal reaction of the surface. So the surface will only react to the weight that the object pushes against. So the object A will push a weight onto this surface, and the surface will react. Remember when we were doing the statics, we were looking at a beam on two supports. Then the beam will have forces acting downwards, and then the surface, the supports, we used to have something like this. We have forces going downwards, you have support on the left, support on the right. Whatever forces, if it is 7 newtons, 5 newtons on that side, these two will react to whatever is going downwards. So in the same manner, this surface is going to react to the weight of the object. So the normal reaction of the surface, it's the weight component. Weight component perpendicular to the surface. Okay, so it is always perpendicular. Perpendicular in this case perpendicular, we know it means 90 degrees. So the weight component is always acting 90 degrees to the surface. So if the object is on a horizontal surface, the normal reaction of the surface, is going to be the weight itself if the object is on a horizontal surface. But if the object is on an incline, we have an object on an incline. In this case, the normal reaction is not equals to the weight. In this one, the normal reaction is equals to the weight, because the weight is what is pushing against the surface. So the surface reacts at 90 degrees equals to the weight. But when it comes to this case, the normal reaction, it is the surface. The surface is reacting, and it is always reacting where? At 90 degrees. So the surface, when it reacts at 90 degrees, it is no longer the total weight that is pushing against it. The weight is always towards gravity. So the weight will be going in that direction. What we have as our normal reaction when an object is at an incline is the weight cos the angle of the incline. Okay, so that's what we'll be doing. You differentiate. If it is on a horizontal, the normal reaction is equals to the weight. If it is on the incline, the normal reaction is the weight always in newtons. We should know how to calculate for the weight. If it's given in mass, we can calculate, we convert it to newtons. It's a weight. So it's the weight cos the incline of this. So in other words, what we are saying is that if we increase the incline, the more we increase the incline, the less the normal reaction, the less contact there is between the object and the surface. So normal reaction should always be 90 degrees perpendicular to the surface. And in most questions that will come across, they will ask us calculate the perpendicular component. They will not straight away ask you to say calculate the normal reaction, but they will use a term like this, the weight component perpendicular. Every time we hear the weight perpendicular to the surface, then we have to know that we are calculating for the normal reaction. Then, like I said, if the object is on a horizontal surface, the normal reaction is equals to the weight. If the object is on an incline, the normal reaction is equals to the weight cos, and whenever we calculate, let's make sure our calculators are in degrees. The weight cos the incline, the angle of the incline of the surface. So that's what we'll be doing. Okay, so then before we can get into detail with that, the other thing that I just want to say is that also friction force depends on how smooth or how rough the surface is. So we can have an object on a very rough surface. This object, maybe it's 100 newtons, that's the weight of the object. And the same object, we put it on a very smooth surface, it's still 100 newtons, but the object is on a very smooth surface. The friction force that this object will experience based on the rough surface is not the same as the friction force that this object will experience based on this smooth surface. So when we come to the issue of now, how smooth the surface is and how rough the surface is, we'll be looking at what is known as a coefficient of the surface. Okay, coefficient of friction. This coefficient of friction, basically it's a ratio between the friction force and the normal reaction. Okay, at this point we already know what normal reaction is. So now it is a ratio between the friction force that is experienced and the normal reaction. In this case, the normal reaction for these two surfaces will always be the weight, 100 newtons, 100 newtons. That is how much the surface is reacting by, 100 newtons. But the friction force that this one experiences and that one experiences will not be the same because of the smoothness or roughness of the surface. So coefficient of friction now gives us an idea of how efficient the surface is, and we'll be calculating coefficient of friction, which will be using a symbol, that symbol for the mu for friction, but this one is just a ratio, so we'll just take that symbol alone to be friction force. Like we have said, it's a ratio between the friction force and the normal reaction. So like I said, the normal reaction depends on the surface. If it is on an incline, the normal reaction is the weight. In this case, it's the weight. So it will be a ratio. Coefficient of friction is a ratio, therefore it will not have a unit. no units for coefficient of friction. It is just a number. It is just a number between 0 and 1, 0 comma something. Not it shouldn't exceed 1, or else the object will not be able to move on this surface. If our object is able to move on the surface, then the coefficient of friction should be less than 1. The closer it gets to 1, then it means the surface is offering too much friction force. But the closer it gets to 0, then the surface is very smooth. Okay, so very rough surfaces, their coefficient of friction is very high, getting close to 1. But if the surface is very smooth, the coefficient of friction is very, very small. Okay, so that's about coefficient of friction. And then the other point that I would like to make is that as you study your textbook, please take note of things like the definitions, things like advantages of friction or applications of friction, and also the disadvantages of friction. So as you prepare for your exams, take note of those things. Okay, the other item that they will ask of us is what is known as the angle of friction. Angle of friction. Okay, angle of friction. So from this example, let me just take one example from this. From this example, what we say is that friction force, if we try to move this object, let's say friction force is acting in that direction. This is our friction force. We try to move this object in that direction. This is our force applied. Friction force is acting in that direction. The normal reaction is going upwards, 100 newtons. Now, in terms of the normal reaction, normal reaction is always at 90 degrees. Normal reaction is always at 90 degrees. So now, what we are saying when we come to defining angle of friction, when we calculate the resultant of the friction force and the normal reaction, when we calculate the resultant, our resultant will be somewhere in that direction. The resultant of these two forces. Resultant of two forces, that should have been covered under forces. The resultant of two forces, in this case, you just do your Pythagoras theorem. You have a normal reaction. For the resultant, we have the normal reaction. Normal reaction, you square, plus your friction force, you square, then you get the resultant of these two. Now, the angle of friction is that angle that we have between the resultant and the normal reaction. This angle here, this is our angle of friction. So now to define this, we have understood what it is. There has to be a resultant of the normal reaction and the friction. So once we get the resultant, then we calculate for that angle. That is the angle of friction. So angle of friction, as we define it, angle of friction is the angle between the resultant of the friction force and the normal reaction. Okay, it is the angle between the resultant of the friction force and the normal reaction. So this angle that we have here, that is our angle of friction. Now, to calculate for it, it's either we get our coefficient of friction or we can calculate it manually, but our angle of friction is equals to tan inverse the coefficient of friction. Tan inverse the coefficient of friction. In most cases, it's either they give us the coefficient of friction or they give us the angle of friction, then we can manipulate those ones. Alright. Now, for most of our syllabus and most of the things that we shall be doing, they will have to be on an incline. Most of the forces, most of the things that we'll calculate, they will be on an inclined surface, not a horizontal surface. If it is on a horizontal surface, then that's an easy question, as provided that the force is a direct force, not an oblique force. Under forces, we did, there are two types of forces. If we have a force acting on an object like that, this one is a direct force. It is, all this force is acting direct on an object. But if the force is acting at an angle, it forms an angle. This is an oblique force. So for now, we just focus on direct forces. Oblique forces, we'll do another video for that. This is our object. On an incline, what we have said is that already in this case, the normal reaction is not equals to the weight of the object. So that's the first thing. Whenever we see an object on an incline, remember that the normal reaction is not equals to the weight. The normal reaction is equals to the weight cos the angle of the incline. And then the other thing that arises is that as we increase the angle, this force starts getting attracted towards the ground, and I call that force which is attracting it towards the ground a sliding force, depending on how you call it, but for easy understanding I like to call it a sliding force. This object is being attracted to slide downwards. So there's another force that comes into action as long as we elevate the angle of the surface. So that sliding force always increases. The more you increase, the more the sliding force, the more it is attracted to slide downwards. You call that force S, sliding downwards. It is the force that is attracting the object to move downwards, and it is a component of the weight. We are not pushing the object. The object, because it is on an incline, it is being attracted to slide downwards. So with this one, we'll define it as a component of the weight parallel. Okay, so take note of those terms, parallel and perpendicular. Parallel to the surface or the incline. It is always parallel and it is always going downwards. It is always sliding downwards, even if the object is not sliding downwards, but as long as it is on a surface, the sliding force exists and it is always attracting the force downwards. Let's take, for example, if this is my surface, as long as the object is on a horizontal, sliding force does not exist. But the more I start, the minute I raise the angle, the minute we raise the angle of incline, even if the object is not sliding downwards, there is a sliding force that is attracting to go downwards. The more I raise it, we see that the object starts to slide downwards by itself, and it is a result of that force which is attracting downwards. If it's not moving downwards, still this force exists, only that it is not big enough to move the object downwards. But the more we increase, the more the sliding force increases and the object will also slide downwards. So sliding force is always in the downwards movement and it is parallel to the surface. So again, in our questions, in our exam, they will not say calculate the sliding force. They'll use terms like calculate the component of the weight parallel to the surface. Okay, then how do we calculate? Our sliding force is equal to the weight sine theta, the angle of the incline of the surface. Okay, keep in mind weight, always use weight. Whether they give us in kgs, convert that to a weight. How do you convert kgs to a weight? You just multiply the mass times your acceleration due to gravity, which is 9.8. Okay, so whatever that we use in our calculations, remember we are looking at friction force. So everything that we are calculating for under this topic will be in newtons, as force, the units for force is newtons. Alright, so sliding force increases the more you raise the angle of the incline, the more the sliding force increases. At such a point, like I was demonstrating, at such a point where the object starts to slide downwards by itself, at that point we have reached what is known as the angle of rest. Angle of rest. Okay, at a certain angle, we keep raising the surface at a certain angle. This theta will reach a certain angle where the object starts to slide downwards by itself, and that angle is known as the angle of rest. So angle of rest, which they might ask, angle of rest, also known as angle of repose. Angle of rest is the angle between the surface and the horizontal. Okay, so this is our horizontal plane. Then the surface, we are raising this surface. So it is the angle between the surface and the horizontal plane. And at this angle, the object starts to slide downwards by itself. So angle of rest is the angle between the surface and the horizontal surface, horizontal plane, at which the object, this object, starts to move or slide downwards, starts to move downwards by itself, okay, by itself, or without any external force applied to it. So this object, without any force applied to it, it just starts to slide downwards. We are not pushing the object, but at a certain angle, the object starts to slide downwards by itself. That angle, that particular angle, is known as the angle of rest or angle of repose. So they might ask for a definition of angle of rest or angle of repose, and this is how you define angle of rest. All right, so how do we calculate, or how do we know this? So at this angle, what is happening is that the more you increase the surface, the more the sliding force increases, and the less the normal reaction. Okay, normal reaction decreases. So the more you increase the angle, sliding force increases, normal reaction decreases. And what we know is that if normal reaction decreases, then the friction force is going to decrease. So now, okay, let's say increase of angle of the incline, or incline angle. So the more we increase this angle, what happens is that sliding force does what? Increases. And then if sliding force increases, what happens to the normal reaction? The normal reaction decreases. Okay, that is what is happening. The normal reaction decreases because of that angle of incline. So now if the normal reaction decreases, what happens to the friction force? Friction force, from what we have, is that the coefficient of friction over the normal reaction. So if we are calculating for the friction force, it's the coefficient times the normal reaction. Now, if this number, the normal reaction, decreases, therefore our friction force is going to decrease as well. So we can say when we increase our angle of the incline, the sliding force increases, the normal reaction decreases. And if the normal reaction decreases, still the same surface. If the normal reaction decreases, then what happens to the friction force? The friction force is also going to decrease. Okay, so those are things that we should keep in mind. If we increase the angle of the incline, sliding force increases because it's pulling downwards. Eventually the object will slide downwards by itself, like we demonstrated. Then the normal reaction decreases. Now if the normal reaction decreases, that means our friction force is going to decrease. We are not changing anything about the surface. The coefficient of friction remains the same, but the friction force will decrease as a result of the normal reaction decreasing. Alright, and at that angle the object will start to move downwards by itself. And also keep in mind, when it moves, it is moving at a constant velocity, not accelerating. So if we bypass this angle of rest, the object will now be moving downwards at an acceleration. It will now be accelerating it will be accelerating going downwards. Okay, at the angle of rest, it is only moving at a constant velocity going downwards. It starts to move downwards by itself. So at the angle of rest, you will notice that the sliding force at the angle of rest, okay, at the angle of rest, the sliding force is greater or equal to the friction force, slightly greater or equal to the friction force. That is the angle of rest. Okay, so the questions that will be coming across in our syllabus, especially at N2 and N3, is that everything will be happening at constant velocity. Constant velocity means there is no extra force that is causing acceleration. Remember, force is an influence that tends to change the state of motion of an object. So force, according to Newton's second law, which we have learned, is that the acceleration is directly proportional to the force, to the net force, and inversely proportional to the mass. So in this case, everything that we'll be solving for will be at constant velocity, which means there is no acceleration. There should be zero, net force should be zero. Okay, so if they tell us how much force should we apply in order to move this object downwards at constant velocity, always our syllabus will be at constant velocity. So if we are moving downwards at constant velocity, therefore our net force is zero. That's constant velocity. The net force is zero. If we say let's move our object upwards, still we need the object to move at constant velocity, which is a net force also still of zero. Alright, so that's what we'll be doing. So if we say let's move this object downwards, how much force do we need to move this object downwards? Friction force will choose to go in the opposite direction. So we have now 1, 2, 3 forces acting downwards, acting on the object. Sliding force always acts downwards. But friction force depends on where you want to move the friction force, and it will oppose that movement. So if you say let's go up, friction force will choose to go down. If we say let's go down, friction force will choose to go up. It is always in opposition. So what we said is that all these three forces should be equal to zero. So what we have is that our downwards movement is the plus. So for down, plus our friction force, then friction force is acting against us, and all these forces, the net force, should be equal to zero. Then that's what, sliding force then. This is our friction force, sliding force, going in the downwards direction, your downwards movement. So these two are working together. Friction force is the one that is opposite. Then everything should be equal to zero. Yeah, so basically this is what we'll be doing, and you calculate. You can simplify this if you want to say, okay, how much force do we need to go down? Therefore, we have our friction force goes to the other side. This guy goes to the other side, our sliding force. Then we are saying our friction force minus the sliding force. That's how much force we need to go downwards. Okay, which is even practical. If you have tried to push something down an incline, you apply less force because the only force you're trying to overcome is friction force. The sliding force is working in your direction. So when you're pushing an object down the incline, it becomes much easier because the only force you need is the difference of the friction force. Sliding force is already helping in that direction. Then you calculate. Also, keep in mind that this friction force is the one that we were calculating from the coefficient of friction times the normal reaction. Okay, so friction force, we calculate it like that. The sliding force is the one that we said is always a component of the weight parallel to the incline. Then we can calculate like that. So we calculate these individually before we can throw them in there, or you can throw them in the formula as you want. You place that coefficient of friction times the normal reaction minus your weight sine theta. Okay, that is all up to you. All right, then should we choose to say let's push the object upwards? Now we are we are trying to move the object upwards. Friction force will say, no, I don't want to go upwards. You're applying this force. Friction force will change its direction and will be going in the downwards direction. So now we notice that friction force is now working together with your sliding force. The force that you need to move upwards, you need more force, because now you need to overcome these two that are working together. Then, like we said, all these forces, when you add them, they should be equals to 0. So we take our going upwards as a positive, so which means this friction force is going against your movement. The sliding force is also going against your movement, and everything should be equals to 0. You can try and simplify this. Force up, these two go to the other side. We have your friction force plus your sliding force, and what we have is that sliding force on that. So in order to move up, you need to really apply a lot of force, which is a sum of the friction force and the sliding force. Then the object will move at constant velocity. Remember, this is all at constant velocity. Our syllabus demands that we do constant velocity at this point. Okay, so that is what we'll be doing. So just try to memorize this. Going up, it's a plus. Going down, it's a negative. Okay, because in our formula page, what they will give us is something like this, plus or minus your sliding force. Okay, and most people, okay, they will not say force, they'll say total force. Okay, total force, friction force plus or minus the sliding force. So just know that if you're going up, it will be a plus. If you're going down, it will be a minus. You're minusing those two forces when you need to go away downwards. Okay, but either way, if you fail to memorize these ones, then you are left to be chancing on your exam, which we don't want to do. So just know that if you're pushing an object upwards, you need a lot of force. If you're pushing an object down the incline, you need less force, you minus. Then that will be fine, and then we'll get our questions.